All right, lesson 7.2 or 7-2, using trigonometry ratios. All right, so let's actually just, I'm going to review a little bit in the last one that we did there too, just to give you guys an idea. So in the last lesson there, we reviewed Sohcahtoa, right? So if you remember, that was sine, cos, and tan. And then the O over H part and the A over H and all that, that's referring to, it's either the opposite side or the hypotenuse, right? And in this last lesson, what we were doing is we figured out, well, for example, what is cosine maybe of the angle? And if you remember, cosine of the angle is the ratio of the, well, cos is adjacent over hypotenuse. So like in this triangle, that would be 4 over 5. And that would be the cosine of the angle. And then if you remember, we took that little, like another step farther, and we said, okay, well, if cosine of the angle, like if that ratio is 4 over 5, then we can go like the inverse of cos, and we can figure out what the angle would have to be. And remember, your calculators have to be in degrees for this to work. That's going to be the case this time too. Your calculators have to be in degrees, or you're going to get funny answers. So that was the last one. That was finding an angle. All right, so now what we're doing is just the other half of it, where if we're given an angle, what's the side length, right? So in this case, they're going to actually give you the angle, and then we solve for the side length. So you guys can see there's an example there, and there's other ones here too. But I think we can just get doing some questions. I think it'll make it'll make more sense to you here. So let's do question number 1. So it says, determine the length of xy to the nearest tenth of a centimeter. Okay, so xy, so it's asking for that length right there. So step number 1, we got to figure out what the names of these sides are. So labeling these things is one of the, yeah, it is probably the most important thing. So if we're looking at this angle right now, that's the one that we're on, and that's my right angle is right there, right? If you can remember from last lesson, one way I always do is I say, okay, right across, right, the opposite side or across from that angle, that's going to be my opposite side. Okay, so that's going to be your opposite, and that's the one we're looking for. And then adjacent, the word adjacent means beside. So the one that's beside the angle, that's going to be this one. So that's the adjacent. And then that would make this other one the hypotenuse, right? That side's going to be our hypotenuse. And the hypotenuse just is usually the easiest one to recognize because it's right across from the 90-degree angle. And the hypotenuse is always going to be your longest side, right? And that's always been the case. You guys are probably used to that by now. So now they have those labeled, right? They've given me this number. They've given me the angle, and I don't have the opposite. So here's what we're going to do. So you guys are going to get tired of doing this. You got to write down Sohcahtoa. Sohcahtoa. All right, so now what I'm after, like what I have to figure out is, am I going to use sine, cos, or tan? That's like the first problem we got to figure out here. So what I do is I go back over to my question and say, well, okay, well, I'm looking for this one, right? That's the side I'm looking for. And they've given me this one. All right, so the two things I'm interested in here are the opposite and the adjacent. Those are the two that I don't even care about the hypotenuse. That doesn't even come up, right? So I look over here and say, which of these deals with opposite and adjacent? Well, that's going to be tan, right? Because tan is opposite over adjacent. So I don't need cos and I don't need sine. I need tan. So then we just write it out. We say, okay, tan, and it's always going to be tan of the angle. So in the last one, we'd say like tan of A, and we solved for it. Now this one, we know the angle. They've given us the angle, so that's 70 degrees. So we're going to write tan 70 degrees, and that's like tan of 70 degrees. Okay, is equal to, and then that's where this comes in. It's tan is equal to opposite over adjacent. So now just make sure you put these numbers or put them in right? So the opposite is what I'm looking for. So I'm going to call that X for a minute. You can call it whatever you like, but yeah, that'll be X. And then over, and then the adjacent was 5, right? That's what the adjacent side length was. So now I can figure this out. I can figure out what X is going to have to be just by doing a little bit of algebra. So what I'm going to do, I'm going to get, I need to get x on its own, right? So I need to get that 5 out of there. So what I'm going to do is I'm going to multiply both sides by 5, right? So I multiply this side by 5, they canceled, and I ended up with 5 over there. So then that's it, really. If I just type in 5 times tan of 70 degrees. So 5 times tan 70 is equal to x. So can you guys right now, I'll give you a second here. Can everybody type this in to make sure you get the same number as me? So you type it in as 5, just everything like it looks, 5 times tan 70 degrees. And if you've done this correctly, you should end up with 13.7 is equal to x. So now, yeah, 13.7, and remember what that is. That's this length that we just found. Okay? That's it. That's the idea. So let's do another one. Because actually, if you guys have this figured out, they're all the same. That's the great thing about trig, and a lot of times kids like this unit, because once you get that one skill kind of figured out here, every one of them's the same. We just might use sine instead of tan, right? Like, but let's do some examples, some more, just to kind of get this down. So looking at this one, it's saying determine the length of Vx, right? So now it's looking for this side. Okay, so again, so this is my opposite, right? That's the opposite of the angle. This would be my adjacent. So again, I'm using tan, right? Tan is opposite over adjacent. So that's going to be tan of 42 degrees is equal to, and then the opposite was 7.2. And then I'm looking for the adjacent. So you guys can kind of see how this changed up though, right? The last one, the x was already on the top. So it was quite easy just to multiply both sides by 5. In this case, I've got the x down in the bottom or in the denominator, right? So the first thing I got to do is I got to get that x out of the denominator. So what I'm going to do is I'm going to get it out of there by multiplying both sides by x, right? So I'll multiply that side by x and they cancel, and then I'll multiply that side by x. Okay, so far I've got x times tan 42 is equal to 7.2. Now, just remember, this tan 42 I got going on there, that's just a number. That's a number like anything else. So we can treat it just like a number. So I'm going to get rid of it by dividing both sides by tan 42, right? So that would cancel those. And I divide this side by tan 42. And then right into your calculator. So we say x is equal to, and then make sure you guys get the same answer as this one as well. Should be 7.2 divided by tan 42. You should get 7.996, right? Which, and wants it to the nearest tenth of a centimeter. Well, that would round up to 8.0 centimeters. Oh, I should have put centimeters in the last one too. Now that I look at that. Yeah, that should have been centimeters. Okay. Okay, like I said, that's it. Now, a couple of things I just want you to know this here, right? That kids get a little bit confused by is in this case, when we're looking for a side length, did you guys notice that we just put it in as just tan 70, like you type it in straight away? That's always going to be the case when you're looking for a side length. And if you go back to the last lesson, sorry, I'm scrolling everywhere. The last lesson we did, remember the way that we found the angle at the end was we went tan -1, right? To go from here, right? We went, or like cos -1 of this, and it gave you the angle. That's always going to be the case. Whenever you're looking for an angle, it'll be like cos -1. And when you're looking for a side length, you're just going to type it in just straight away. All right. And back where we were. Okay, so now word problems. Yeah, let's do this word problem. So horizontal distance of 200 meters from the base of an observation tower. The angle between the ground and the line of sight to the top of the tower is 8 degrees. How high is the tower to the nearest meter? Okay, so they've actually drawn what's going on there. And they've told us the horizontal distance. The horizontal is, oh, that's weird. Horizontal is that way. Picture, come back, there we go. and that's 200. Okay, so this is just a triangle, right? And they've given us the adjacent side, and we're looking for the opposite. Okay, so we can call that x over there. So again, these have all been tan so far. So we'll say tan of 8 degrees is equal to, and then it's opposite over adjacent. So that'll just be x over 200. And then I multiply both sides, you know, but one thing you guys are probably getting a little bit better at now too is we can do these things quite easy. Like, do you notice if when I go times 200 and times 200, you know, the effect of this was just, so those are cancel and everything, right? But in the end, what happened is if this is on the bottom of this side of the equation, you guys kind of see that you can just like move it to the top of that side of the equation. You just like move it diagonally. So that's quite simple. You can just do that in your mind really easily once you get good at this, right? So you can write out multiply by 200, multiply by 200 and cancel them, or just move that 200 up to the left there, right? So that's just 200 times tan 8 degrees. Okay, so that would be 200 times tan 8. So you end up getting 28 points, and it says to the nearest meter, so that's just 28 meters. Okay, more examples there. What else we got here? Let's do this one. They're all really the same, so let's do this one, and I think we'll be good. Another word problem. So from a radar station, the angle of elevation of an approaching airplane is 32.5 degrees. It says the horizontal distance between the plane and the radar station is 35.6 kilometers. How far is the plane from the radar station to the nearest tenth of a, actually both kilometers, nearest tenth of a kilometer. So now, how far is the plane from the radar station, right? Just, if you didn't, like, this one's pretty easy because they actually gave us the picture, but if they didn't give you a picture and you had to draw it out, just remember that how far it would be the line of sight, just like directly to that thing, right? So just, sometimes these word problems get a little bit confusing. So just, yeah, try to picture what you're doing there. Anyway, so in this case, they've given us this side would be the adjacent, right? It's the one beside it. And now they've given us the hypotenuse. And I don't even care about the opposite, right? That's the one I don't even care about this time. So if that's the case, I'm going to say, well, start out by writing Sohcahtoa. All right, so now they've given me the adjacent, and I'm looking for the hypotenuse. So those are the two things I'm interested in here. So which of these deals with adjacent and hypotenuse? Sine, cos, or tan?
The C1.
The C, yeah, the C1. Yep, perfect. So cos. Okay, so that's going to be cosine, and then it's always cosine of the angle. So cosine 32.5 degrees is equal to, and then the adjacent was that one, right? The one they gave us. So 35.6 over, and then I'll just call that x. Okay, so now we could multiply both sides by x and bring it up there and everything else, right? But like I said, you can just move these things around pretty easily where I could say, okay, I know the net result of that is going to be the x is going to go to the top, right? So I can just move that guy diagonally up to the top. So if you move that up to the top, that would be x times cosine 32.5 degrees is equal to 35.6. And then again, I could divide by cosine 32, you know, on both sides and cancel them. But again, if it's on the top of this side of the equation, then it can just move to the bottom of that side of the equation, right? These things can just like move diagonally. You can just like shift them around. So in the end, you've got x is equal to 35.6 over cosine 32.5 degrees. So for that one, we'd have 35.6 divided by cos 32.5. So you'd end up with 42.2 kilometers. And then one thing to keep in mind when you guys are doing these questions double check to make sure it makes sense. Because I'll give you a little hint here that if your number makes sense, right, then you're like the chances that you're wrong are like almost zero, right? Like if you've got like a number that's probably right, you know, then it definitely is right. Like if you're close, it's definitely right. And what I mean by that is that if you got a number here like, I don't know, like 500, then if this was 35.6, you can probably use your reasoning to tell that that wouldn't be 500, right? There's no way. But looking at my answer of 42.2, if this is 35.6, the hypotenuse is always going to be longer. Yeah, that makes sense, right? That's in the right ballpark. So then once you know you're in the right ballpark, you're going to be right. You know what I mean? Like it's like if you're going to be wrong in these questions, you're usually going to be really wrong. You know, like it's not usually that if you're wrong, you know, you'd end up with 39 kilometers or something. If you were wrong, like that means that you would have done something wrong in here, and you would have been really wrong. So yeah, just double check it to make sure it makes sense. And then if it did, you can be pretty sure. Like it can happen, but you can be pretty confident that you got that one right. Okay, and that's it. Like I said, they're all almost exactly identical, right? You're just either using sine, cos, or tan. So this is probably one of the most important skills for you guys for math up until grade 12 though. So really make sure you guys are putting effort into this because this is going to come up a ton next year in 20-1 and 20-2. And it's also going to, if you guys take physics 20, this is like half the course, right? Like we do tons of trigonometry in physics 20. So really important skill. So make sure you guys are putting effort into it, okay? And then good news is we've only got 2 more lessons because 4.3, here, actually, sorry, I'm going to turn the recording off.